Good afternoon. Welcome to the forecast discussion for March 24th, 2014. It's currently 12:47 p.m. Well, we have an interesting storm developing out there in the Gulf of Mexico and eventually in the Atlantic. Is it going to really hit us? I'm going to break this down for everyone, and you kind of have to be able to use models in such a way that you just don't follow one. You take bits and pieces of each one and kind of work out the way that this storm should evolve. And hint, for most people, it's not going to be all that big of a deal. So first, let's look at the observations. It's clearly cold out there. Temperatures are in the lower to mid 20s over the far northern interior. It's just brutally cold out there for this time of year. We should be at 57 degrees right now. It's 22 in Scranton. It's 28 in Allentown. 29 in Philadelphia. The warm spot, 33 in Atlantic City. Party there. Temperatures are in the upper 20s to lower 30s in the New York City metropolitan area. It's cold. There's no getting around it. It's just cold. It's a very cold air mass, and that's part of what's creating this potential for this storm to really explode is the thermal gradient difference from the very warm waters in the Atlantic and the warm air mass that's over the Atlantic, and this very cold, brutally cold air mass for this time of year over the Philadelphia and New York City metropolitan area, and really over much of the eastern United States. So we have our cold air in place. There's no doubt in my mind that anything that does fall is going to be snow, but how much? How far to the east will this storm actually be? Well, first let's take a look at what's actually out there right now, and we're going to look at the radar, and currently we have nothing over us right now. It's high and dry, clear skies out there. Here's the developing storm in the Gulf of Mexico. A lot is rather disorganized, not really much going on here. The storm is a bit far off to develop still. We still have some time to wait. By tomorrow at this time, we should see an organized area of precipitation developing over the eastern Gulf of Mexico. And by tomorrow afternoon, let's say around 2-3 p.m., we should see this starting to come together very nicely off the southeast coast. That's if everything works out as planned, of course. And that's the key here. Timing is key with this whole storm in terms of the interaction of disturbances. So let's take a look at the infrared satellite picture here. You can see high pressure is in control. Not much really going on right now. Here we have one disturbance down here, another one over the plains, another one over the Rockies. They're all going to combine, and we have another one out over the Pacific Northwest, which I'll show in just a moment. So for today, cold, temperatures in the lower to mid 30s for highs, well below normal for this time of year. For tonight, scattered cloud cover for the most part, clear skies to scattered cloud cover. Temperatures falling, again, well below normal for this time of year in the mid to upper 20s. We should be around 38, 37 degrees right now for lows, and we're going to be about 10 degrees below that. And then as we move into Tuesday afternoon, temperatures in the upper 30s to lower 40s. Again, chilly, but above freezing. That's key. See, this air mass, although cold, is rapidly modifying. You could thank the March sun for that, and that's why it's important to recognize what time of year it is. These air masses don't have as much staying power as far as the cold air masses because they're modified much easily over the land because of the March sun. So let's take a look at this water vapor satellite picture, and I kind of zoomed out here. Let me zoom in a little bit here. And okay, so here is all the players here. First of all, we have a disturbance in the Gulf. We have a disturbance off the southwest coast. It's kind of slowing this whole setup down. This upper level low is heading towards the west coast. Starting to pump up the ridge just a little bit. And here's our disturbance that's going to phase with the disturbance here. So we have 1, 2, 3, 4. Okay. This disturbance pumps up the ridge, allows this disturbance to amplify and dive south. Although it's being held up right now because of this disturbance. And that's a key point here. What we're seeing here is this disturbance is moving a little bit slower. So the key true storm track, the primary storm track is going to remain out in the Atlantic. No doubt about that. The worst impacts from the storm out in the Atlantic. The question now is not whether the actual storm will hit the Philadelphia and New York City metropolitan area, because it really won't. What we're dealing with now is called an inverted trough, which is a mesoscale feature. But what's tricky about this forecast is that in order to forecast for the mesoscale feature, you have to have the synoptic features forecasted correctly. They kind of one in the other. And I'll explain how that works on the model guides here. I have the NAM and the GFS model guides up. So what's key here is this disturbance here dives south, interacts with this disturbance, and the bridge or the phasing area between the two disturbances stretches the atmosphere and creates your inverted trough. But if one disturbance is, let's say, a little bit too fast, like the subtropical disturbance, or the polar disturbance is too slow, that development of the inverted trough is not as impressive. So you have to take that into consideration here, especially with the data that we have in place, the observations we have in place. Okay? This isn't model guidance, this is actual happening right now. So the fact that we're seeing this is why the GFS is not as impressive, and a lot of the global models that are coming out right now are not as impressive. In fact, a lot of them are a complete miss. But then the mesoscale models, like the NAM model guidance, shows a moderate amount of precipitation, let's say for the immediate New Jersey coast, especially around Atlantic City. Don't get ahead of yourself yet, though. I'll explain why we can't go full board on the NAM either. So let's take a look at the model guidance here. Okay, and now we'll fast forward to Tuesday afternoon here. So here's the key here. We're at 30 hours. Here's our disturbance diving south. This is our polar disturbance. Pretty robust. I think everyone would agree with that. Here's our subtropical disturbance. And here is the surface reflection of that energy starting to interact. You see, that's even showing up on the GFS model guide. So we can see that here as well. Moving forward, actually, let me show you the NAM model guidance at the same time here. Same kind of idea. Now, the NAM model guidance is a little bit faster with this disturbance, the polar disturbance. Just a tad. It's very slight, but there's just a slight difference. And that's the key difference there. Right there. Is the polar disturbance that fast? That's the key. Because you see by 36 hours, even on the GFS, we see that interaction take place. And then at 42 hours, everything's getting kicked out in the Atlantic because, hey, guess what? There's no blocking in the northern Atlantic. So everything is pushed east because you have a nice little upper level low knocking down the ridge. Progressive pattern, here it comes. So on the GFS model guidance, much of the precipitation is held off the coast. It's a very light precipitation event. Strong winds, definitely anywhere from 15 to 30 miles per hour on the coastal plain. As you move right along the immediate coast, look for 20 to 40 mile per hour sustained winds, gusting over 40 miles per hour in some locations. Eastern Long Island, it's going to be very windy out there Tuesday night into Wednesday morning. But as far as the precipitation is concerned, well, a lot of it's going to have to depend on where this mesoscale inverted trough sets up. See, on the NAM model guidance, in that same time period, the phasing is a little bit faster. So you get this little trough here that's trying to hang back. And the precipitation is a little bit more enhanced. But the timing of this disturbance doesn't seem right on the NAM. Or on a lot of these mesoscale models. Because it's kind of a dual question of mesoscale, small scale, and synoptic, large scale. Mesoscale models do not handle large scale equations very well. Or questions, let's say. On the flip side, global models like the GFS or the Canadian model guidance or even the European model guidance do not handle mesoscale features very well because they're too small. So you kind of have to merge them together and kind of work out the solution that's somewhere in between here. So what we have here is a situation where the primary storm is going to remain out in the Atlantic. Okay, I think that whole debate is done. This is moving east. It's not going to shift west. It's not going to redevelop and pull into, 100 miles off the New Jersey coast or anything ridiculous like that. It's staying out there because there's nothing to keep it out there, to keep it along the coast. Just isn't. Okay, the debate's done. It's over. There is no blocking in the Atlantic. The pattern is too progressive. This storm is remaining out in the Atlantic. The question now comes down to, as that phase is happening, and as energy is transferring towards the Gulf Stream, how long and how impressive will the inverted trough be? So, what I've done, and I did it this morning, is set up this forecast here. Now, for most locations away from the coast, I have in zone 1 a trace of 2 inches. You pretty much focus on the trace here. For everyone from Philadelphia on west, Hartford over much of northwestern Connecticut, the Hudson River Valley, northern New Jersey, New York City, trace to 1 inch. Much of New Jersey away from the coast here, a trace to 1 inch. Could see an isolated 2 inches on grassy surfaces. Now, the coast. Let's say from southwestern New Jersey, we'll cut across Dover in Delaware here, up through central New Jersey, around eastern Monmouth County, clipping the south side of Long Island. That's where you'll see the best potential in zone 1 for 2 inches of snow. Now remember, a lot of the mesoscale models, and I'll zoom in on this. Let's zoom in on this real fast here. Bear with me. Okay. A lot of the mesoscale models, they have this portion right here. This is likely the part that's a bit overdone here. Even still, the temperatures at the surface are marginal. They're just hitting freezing along the coast. But remember, the pavement's pretty warm. So on the pavement, a lot of this probably won't be accumulating. But like on your grassy surfaces, they will. But as a result of this setup here, again, if you take onto the idea that this is probably a bit overdone, but the GFS probably is too weak, you're kind of in between, this is probably further out in the Atlantic, more like out here. And so as a result, as you kind of mix the two solutions together, you're probably around 2 inches or so. But then at the same time, because the lifting is so strong in the NAM right along the southern New Jersey coast, it has almost nothing in the New York City metropolitan area or in Long Island. I mean nothing. I mean, look at it, it's bone dry. That probably is a bit overdone as well because the lifting's overdone on the NAM. So that brings me back to here again. So again, I'm looking around 2 inches in this area here. In zone 2, this is where you have 1 to 3 inches mostly on cold surfaces. The idea here is that the storm's going to start to bomb out well out in the Atlantic. A nice impressive precipitation shield will set up. And a lot of this is going to be occurring around midnight and beyond. So there's going to be a better potential for snow to accumulate because it's colder. So you got 1 to 3 inches in this zone. And all the way out in far eastern Long Island and eastern Connecticut, like extreme eastern Connecticut, right on the border, I'm looking at 3 to 5 inches on cold surfaces. Most locations are going to be around 3, but I wanted to throw that 5 inch just in case you get one of those rogue bands that sets up. But most part, around 3 inches, and on pavement, 1 to 3 inches. Again, most likely around that 1 to 2 inch area as that snowfall is developing. The worst impacts from this storm is going to be the wind. Winds are going to be, again, 15 to 30 miles per hour over much of the region, 20 to 40 miles per hour right along the immediate coast and over portions of eastern Long Island. Wind gusts are going to be over 40 miles per hour. It's going to be a very windy day on Wednesday, that is for sure. And also cold, with temperatures struggling in the upper 30s to lower 40s on Thursday afternoon as this storm is exiting. The good news is that once this storm is gone, and it will be moving rather quickly because it is a progressive pattern, once it exits by Thursday, high pressure will take control, temperatures rebounding to the lower to mid 20s for lows, mid to upper 40s for highs. By Friday, we're warming up very nicely. Watch out for a few scattered showers, but other than that, you're looking at temperatures in the mid to upper 30s for highs, upper 50s to lower 60s. Mid to upper 30s for lows, upper 50s to lower 60s for highs. And on Saturday and Sunday, again, we're going to have a few disturbances moving through with some scattered showers, but not anything of winter, snow, or anything of that nature. Just scattered showers. Temperatures on Saturday and Sunday range from the upper 30s to lower 40s for lows and mid to upper 50s for highs. And then on Monday, upper 30s to lower 40s for lows, mid to upper 50s for highs, possibly even a few lower 60s, just in time for the start of the baseball season for the Mets, the Phillies, and the Yankees. Spring-like conditions are in place with a nice zonal pattern from the Pacific to the Atlantic, which means no major storms after we get rid of this one that's pretty much going to miss the region. Well, that is your forecast discussion for today. I hope everyone understands exactly what's evolving here. Again, you can't take one model completely verbatim. Either one. On the GFS, the NAM, the European, the Canadian, you kind of have to combine these models together because you're answering two different questions in meteorology. One synoptic, the phasing situation, and one mesoscale, the inverted trough. The synoptic equation influences the mesoscale equation. So you take them both together, you phase it together, you use your brain, work out a couple of equations, and that is how you get that forecast. Have a wonderful day out there, and as always, stay safe out there.